Welcome to the chemistry crash course. Today we are going to discuss about some points. In our last class we discussed about the certain definitions of the isotopes and isobars, and today now we are going for the isoelectronic species. Isoelectronic species, here these are the atoms or the ions or the molecules which are having the same number of the electrons. These are having the same number of the electrons. Let us go for the example. So in case of these species, same number of electrons will be there. Same number of electrons will be there. Example, O2 minus and F minus, Ne, Na plus, Mg plus 2. All these consisting of the 10 electrons. If you calculate, these all consisting of the 10 electrons. And one more set of the example, N2, CO, Cn minus, No plus, all these consisting of the same number of the electrons. So those are 14 electrons are present in this. Okay. So the isoelectronic species means these are the atoms or the ions or the molecules which consisting of the same number of the electrons. Clear? So next, isosters. These are the molecules which are having the same number of the atoms as well as the same number of the electrons. Same number of atoms and electrons. Same number of the atoms and electrons. These are having same number of the atoms means here 2 atoms are there. In this molecule 2 atoms are there, here also 2 atoms are there. If you calculate the electrons, here N2 means 14 electrons. If you calculate the electrons for the CO means that is also the 14. It means isosters, these are the molecules which are consisting of the same number of the atoms and same number of the electrons. Example for the isosters are N2 and CO. If you know, if you calculate for the electrons, those will be same in these two, and the number of the atoms are also same in these two. And similarly, one more example, CO2 and N2O, these also consisting of the same number of the atoms and same electrons. Clear? So next one is nuclear isomers. Say here nuclear isomers, these are having the same atomic number and same mass number. Same atomic number and same mass number, only the difference is the radioactive properties will going to be different. The radioactive properties are different, and let us go for the one example, that is 35Br80, that is bromine we took, and these two are having the same atomic number and the same mass number, but the difference is that half-life period for these two elements are different. One of the element which is having the half-life that is 4.4 hours, and one more is having 18 minutes as its half-life. So it means what? That is nuclear isomers means the elements which are, or the isotopes which are having the same atomic number and same mass number, but the difference is in the radioactive properties, that will going to be vary. That is what we called as nuclear isomers. So these are the further 3 more terms which we can use. Isoelectronic species means which are having the same number of the electrons, and then in case of isosters, same number of the atoms as well as same number of the electrons will be there, and in case of the nuclear isomers, the atomic number and mass number both are same, only the difference is in the radioactive property. Okay, I hope these terms are clear for you people, and let us go for the one more important bit of the topic, that is electromagnetic radiations. So the electromagnetic radiations here are electromagnetic waves. Electromagnetic radiations, or these are also called as electromagnetic waves. The James Maxwell proposed that, James Maxwell is the scientist who proposed that light and other forms of the radiations, propagate in the space in the form of the waves, and those are associated with electric and magnetic field. Such radiations are called as electromagnetic radiations or electromagnetic waves. So let me draw the diagram. So light and other forms of the light and other forms of the radiations propagate through the space in the form of the waves, and these waves are associated with electric and magnetic field, Such radiations are called as electromagnetic radiations, or these are called as electromagnetic waves. Okay. So, let us go for the properties of the electromagnetic radiations or electromagnetic waves. The first property says that the electromagnetic radiation is associated with electric and magnetic field which are perpendicular to each other, and also the direction of the propagation of the wave is also perpendicular to it. The first property is that the electromagnetic radiation associated with electric and magnetic field which are perpendicular to each other, and also that is perpendicular to the direction of the propagation of the wave. So, this is the first property of the electromagnetic radiation. And second property is the electromagnetic radiations, all the electromagnetic radiations move with the same velocity, that is the velocity of the light. Similar to the velocity of the light, all the electromagnetic radiations will going to transmit with the velocity of 3 into 10 to the power 8 meter per second, that is same as that of the velocity of the light. Okay. So, these are the two properties of the electromagnetic radiations, and also these electromagnetic radiations does not need any material media for the propagation. Okay. So, these are the properties of the electromagnetic radiation. First one is the electromagnetic radiations are associated with electric and magnetic field which are perpendicular to each other and also perpendicular to the direction of the propagation of the wave. And the second one, all the electromagnetic radiations move with the same velocity, that is equals to 3.0 into 10 to the power 8 meter per second, that is similar to the velocity of the light. And these electromagnetic radiations does not require any material media for the propagation. Clear? So, all these are the properties. Next, let us go for the characteristics of the electromagnetic waves or electromagnetic radiation. So, the first one is wavelength. Wavelength is indicated by the letter lambda, and wavelength is nothing but the distance between the two adjacent crests. These are the crests and these are the troughs. These are the troughs. Okay. The distance between the two adjacent crest or distance between the two adjacent trough is called as wavelength, and this is what we indicated with the lambda. Okay. And then frequency. Frequency is the number of the waves which are passing through a given point. Suppose if I giving a point, the number of the waves which are passing through a point per second is called as frequency. The number of the waves which are passing through a point, given point per second is called as frequency, which is indicated by nu, and that is nu is equals to C by lambda, which is the formula used for your problematic section. Okay. Nu is equals to C by lambda, where C is the velocity and lambda is the wavelength. Now, we understood what is wavelength. Next, go for the velocity. Velocity is the distance travelled by the wave per second. The distance travelled by the wave per second is called as velocity, and if we come across the formula of velocity, nu into lambda. C is equals to nu into lambda. So, this is how we can say that what is velocity, the distance travelled by the wave per second. Next, amplitude. Amplitude is either the height of the crest or depth of the trough. Amplitude is the height of the crest or depth of the trough, and it is indicated by a letter A. And then amplitude indicates, or it will going to tell us the brightness or the intensity of the radiation. Amplitude gives the idea of the intensity or brightness of the radiation, intensity or brightness of the radiation. And the last one is wave number. Wave number is the number of the wavelength per centimeter. Wave number is indicated by the nu bar, and that nu bar is equals to 1 by lambda. The number of the wavelength per centimeter is called as wave number. So all these are the characteristics of the electromagnetic radiations or electromagnetic waves. First one is wavelength, the distance between the two adjacent crest or trough is called as wavelength, which is indicated by lambda. And next one is frequency. Frequency is the number of the waves passing through a point per second, and frequency nu is equals to c by lambda. Okay. And then velocity is the distance travelled by the wave per second, and the velocity c is equals to nu into lambda. And next one is amplitude. It is the height or the depth of the crest and trough. It indicates the intensity or the brightness of the incident radiation. And last one is wave number. Wave number is indicated by nu bar. That is, the number of the wavelength per centimeter is called as wave number. Nu bar is equals to 1 by lambda is the formula for the wave number. So all these are the characteristics of the electromagnetic waves or radiation. I hope so you got the points. Next, electromagnetic spectrum we are telling. We are using the term spectrum here. Electromagnetic spectrum. See here, electromagnetic spectrum is nothing but the arrangement of the different types of the electromagnetic radiation. Whatever we now said about the electromagnetic radiations, which are the electromagnetic radiations? Microwaves, IR, visible, UV, gamma rays, X-rays, radio waves, all these are the electromagnetic radiations, and these electromagnetic radiations are arranged in a definite order. That is, the arrangement of the different types of the electromagnetic radiation in the increasing order of their wavelength. This is very important. In the increasing order of their wavelength or decreasing order of frequency. Decreasing order of frequency. So what is electromagnetic spectrum? Electromagnetic spectrum is the arrangement of the different types of the electromagnetic radiations in the increasing order of their wavelength or decreasing order of the frequency. And electromagnetic waves are like microwaves, IR, visible, radio waves, X-rays, gamma. All these are the electromagnetic radiations. Clear? So all these are the whatever the characteristics are there, and these formulas are very important for the numericals. Clear? So we'll continue the next concept in our next class. Thank you. Let us go for the solar spectrum and atomic spectrum. See here, solar spectrum is the spectrum which is obtained by with the help of the sunlight. See here, when the sunlight is passed through a prism, it will going to split into 7 colors. It will going to split into 7 colors. That is, we are going to get a spectrum. When the radiation or when the sunlight is passed through a prism, it will going to split up into 7 colors. That is what we are going to get the spectrum. If this spectrum is obtained by passing through a sunlight, means that is what we called as a solar spectrum. Okay. Here what happens? The white light is, that is, white light splits into 7 color. That is what we called as dispersion. Dispersion is the process of the splitting of the white light into 7 colors is known as, or into different colors is known as dispersion. And then there is we are going to get a series of the color bands, a series of the color bands are obtained. A series of the color bands are obtained. This is what we called as spectrum. While the white light is splitting into, white light split into 7 colors, that is what we called as dispersion. Okay, and these 7 colors are obtained in the visible region, that is violet, violet, indigo, blue, green, yellow, and then orange, red. All these are the different colors of the different wavelength and frequency we are going to get in the visible region. Suppose if we are studying the radiation which is emitted from any atom, suppose the radiation which we are passing through a prism, that is this radiation is obtained from any atom, means that is what we called as atomic spectrum. Clear, simple it is. Solar system, solar spectrum we are telling means we are passing the sunlight. If we are telling atomic spectrum means we are taking that radiation from, that radiation is emitted by any atom, or that is what, by any atom, that is what we called as atomic spectrum. Okay. The atomic spectrum is of two types. One is emission spectrum, one more is absorption spectrum. Here emission spectrum is obtained when the light is emitted from the any substance. When the light or the radiation is emitted from the any substance, when it is analyzed, suppose there is a one substance and it will going to emit the light. These emitted light are analyzed. These emitted lines are or radiations are analyzed, and during that time whatever the spectrum, that is the pattern of the spectrum obtained, that is the emission spectrum. And this emission spectrum consisting of the series of the lines having the definite frequency. There is a series of the lines will be obtained in the spectra, series of which are having the definite frequency. That is what we called as a line spectrum. So emission spectrum is the spectrum which is obtained when analyzed the emitted radiation from the substance, and these consisting of the definite frequency lines. That is why here in case of emission spectrum we can tell that the line spectrum is obtained. And one more type of the atomic spectrum is absorption spectrum. Okay, absorption spectrum, when a white light is passed through it, when a white light is passed through any gas or salt of the solution of the any salt, when a white light is passed through a gas or solution of the salt, during that time what happens, some of the rays or some of the radiations are transmitted, some of the radiations are transmitted. When these transmitted radiations or, and those are due to absorption of the certain radiations. For example, there is a substance, I am passing a white light, okay, or any radiation. So certain radiations are absorbed and certain radiations are transmitted, and these transmitted radiations, the wavelengths of the transmitted radiations are corresponding to the absorbed radiations. So we can say that the absorption spectrum which is obtained, how it is obtained, when a white light is passed through a gas or the solution of the salt, some of the rays are transmitted and some of the rays are absorbed. When those are analyzed, we are going to get a spectrum pattern, that is the absorption spectrum. Here in case of the absorption spectrum, we are going to get the dark lines, and these dark lines are due to or these wavelengths are corresponding to the wavelengths of the absorbed radiation. So here the transmission is due to the absorption of the certain radiations, and here the lines which are obtained are dark. That is why we can say that in absorption spectrum the dark lines are available, while in case of emission spectrum the lines of the definite frequency are obtained. Here we can going to get the line spectrum. Okay, this is how we can explain about the solar spectrum and then atomic spectrum and the types of the atomic spectrum. Okay, in our next class we are going to discuss about the hydrogen spectrum. Thank you.